I'm good.
Good. I think we left off at about here.
What was the last thing we did?
That problem right there.
Yeah, we did that.
Okay. However, let's go back. I just want to spend 2 minutes on this. We had a problem where you had $100 earning 9% for 5 years.
Okay.
Asked you how you would do it, and you said you would take 100. You would take 100, multiply it by 1.09. That's what you'd have at the end of the first year, right?
Yeah.
And then you would take that, multiply that by 1.09.
Yeah.
And you would do that 5 times because it was 5 years.
Yeah.
And that was the natural way for you to do it, and I don't blame you. That's the way I would do it too. Notice that that is exactly that. In other words, R is 0.09. So I have 100 times 1.09 to the 5th power. That's how I get the final answer. In other words, this formula is the same as what you did intuitively. See why?
So, yeah.
Okay.
So so
it doesn't matter the order you do these in.
But I should, instead of writing them all out, I should just take the amount. And
well, it's certainly easier, yeah. If the problem would have been after 15 years, then it's going to be much easier to get that answer than it's going to be to get it the way you did it.
Or I could just use my calculator and raise it to whatever power
Exactly.
Yeah.
Here's the difference, is that 100 times 1.09 to the 5th, you can do this part first and then multiply it by your beginning amount. You don't have to do this part first. And then take that answer and multiply it by 1.09. You see the difference? The formula, this formula up here, presumes that you take the 1 plus r and you take it to whatever power it is. Then you take that answer and you multiply it by the beginning principal. Whereas intuitively, you took the beginning principle, multiplied it by one of those, then you took that answer and multiplied it by another one, and you took that answer and multiplied it by another one up until 1.09 had been multiplied 5 times. But it's the same.
Yeah.
Only that's much easier. What I just did there. Because if you have a calculator, you just need to do 1.09 to the 5th. It'll give you an answer and multiply that by whatever your beginning principle was. All right, I just wanted to make that comment because you were doing it correctly. You just weren't seeing that the way you were doing it was the same as that formula. What is the square root of 162 equal?
Let me put it on my calculator.
No, that's not how. In other words, your calculator's
I got a fact there, right? I got a fact there.
Exactly.
Okay, so
Factor the number 162. Now, let me give you a hint. First of all, list your perfect square numbers for me, starting with 1, 4, 9. Keep going.
1, 4, 9. Crap.
That's
14.
1 squared. Hold on. That's 1 squared. That's 2 squared. That's 3 squared. What's 4 squared?
16.
Keep going.
20. Wait, 25. 25.
Keep going.
Oh, okay. 36.
Keep going.
49.
Keep going.
64.
Keep going.
81.
Stop. When you are looking to simplify one of these radicals, what you're looking is to factor it into two numbers, one of which is a perfect square number. And the biggest one you can find is going to make the problem go the quickest. In other words, maybe I can divide that by 9, which I could.
It's 81, right?
Ah, that's the easiest one.
2 and then 89.
One.
So it's,
That's always the step you want to make, and you want to write it out like that. So what's the answer?
do you factor out the 81 after that, or no?
Simplify what's the square root of 81.
Oh, yeah. 9. So 9 root 2.
That's the answer.
Okay, yeah.
And it's always going to be the answer is this part cannot be taken down anymore.
Yeah.
In other words, if that cannot be factored down, then you got your final answer. But let's go back a second. And I could have done this another way. I could have done it square root of 9 times square root of 18. Right?
Yeah.
In other words, I could factor it however I want. As long as one of them is a perfect square number, well then I can do it. Okay, so this produces 3 root 18, but that's not simplified all the way down because now I can do 3 times root 9 times root 2. Notice that I'm always factoring that.
Yeah.
And that pulls out another 3.
So it's 6
with
or 9.
Not 6, but 9 root 2. Same answer I got before. It just took me 2 steps longer. So if you want to do these the shortest possible way, find the greatest possible factor that you can.
Yeah.
You can do them the slow way. There's nothing that prevents you from doing it this way. It just takes more steps to get to the same answer.
Yeah.
All right. Here, let me scroll down a little bit so we can look at this. These are a little different because they're not numbers, they're variables. So let me ask you a couple things. What's the cube root of x cubed?
Is it... Crap.
X.
Yeah, it's just X. Yeah, I was going to say you just cancel out the 3, right?
And another way, the easier way to figure that out is there's the x cubed, there's the cube root, apply the rules of exponents, and you get this.
Yeah.
This is the way you'll never get it wrong, is if you do it that way.
What's the rule of exponents?
that if you have double exponentiation going on, you multiply the exponent.
Multiply them together. Yeah, okay, that's what I thought.
Okay? In other words, if I had two, let's say I had 2 cubed to the 4th, rules of exponents tell me that that's what? 2 to the what?
It's, wait, say again?
Well, what's the answer to this problem? 2 cubed to the 4th power is equal to what? Using the rules of exponents, it's 2 to the 12th. Yeah.
2 to the 12th power.
That's all. That's what I
The thing that was confusing me was the 2 and the, yeah.
You don't add the exponents, you multiply them.
Yeah.
If I had 2 cubed times 2 to the 4th, now I add the exponent. So those are the rules of exponents. You have to know what to do with the exponents in this section here. Okay? So we're going to take these. You always take them one variable at a time. And one way to look at this is, first of all, this part here is x, outside the radical sign. And now I have inside the radical sign the 5th root of y to the 6th.
Uh-huh.
Well, let's examine, that's just part of it, I understand. I still have this z to the 3rd, but the way to handle these is always variable by variable. Okay? So, what is this equal to?
y1?
Kind of. It's the 5th root of y to the 5th times the 5th root of y to the 1st. First of all, do you see why that's true? All I'm doing is separating the y to the 6th into a y to the 5th times a y to the 1st. If I said, what was y to the 5th times y to the 1st, the answer would be y to the 6th. So if I say, what's the 5th root of that? Well, then it's the 5th root of y to the 6th, which is what we're dealing with. We're dealing with the 5th root of y to the 6th in the problem. Alright. I want to make sure you understand this, and I don't feel like you take this completely separate problem. Here, I'm going to write a whole new problem here.
Okay.
Do you see why I can write that as this?
Yeah, because...
Yeah, you can always separate stuff. That's a multiplication sign. Whoops.
Yeah.
And I need a 5th root there also. In other words,
when you multiply, you add the exponents.
Yeah, exactly. Okay. So if that is a true statement, then the answer of this is the 5th root of y to the 5th, which is what? What's that part equal to?
It's 5y, 6th root of y divided by the 3rd root of y.
The 5th root of, in other words, the nth root of
because you divide them.
N, those n's cancel, and it's equal to y.
Yeah.
So it doesn't matter if it's the 5th root or the 6th root or the 3rd root or the 4th root. If
As long as
you
it's
have the same number inside as you have the root, then it's equal to the variable. But I still got the rest of it. Still multiplied by the fifth root of y. So that's what this becomes. And the goal here is to always pull out either a whole number or a whole variable. Notice that I was able to pull out a complete y.
So that would be the answer, y times 5y?
Not 5y, it's y times the fifth root of y.
Yeah, that's what I meant by like 5y.
And you could write that in a number of ways. You could write that like this. But usually if they give it to you in radical form, then they want some form of radical form back as an answer. So they probably prefer this answer here that I have at the bottom. Now, we're not done. All we've done is the x part and the y part. Let's look at the z part. Okay, so, and you can always do it this way. As long as everything's being multiplied, then you can do it variable by variable. Well, notice in this case, I cannot pull out anything.
Yeah.
That's my answer. The fifth root of y cubed. If it was the fifth root of y to a power greater than 5.
Wait, why y? Why?
Excuse me, I didn't mean y, I meant z.
Okay.
Yeah. So in other words, that is simplified.
So the answer in total is like x, y times, yes, times, or root 5y, z3.
You got it. Z cubed, not z3.
Yeah.
Not
when I say that,
Z3 is the same as that. And
yeah,
that is not the same as z cubed.
Yeah, but when I say it like that, I don't mean it like that, trust me.
Okay, I know. I just always...
And I wouldn't write it like that.
Point to correct the students when they verbalize it wrong, just so you won't do it again. In other words, it's one of the actual advantages of online tutoring is it forces you to verbalize stuff. Whereas usually in a class, you don't have to verbalize stuff, ever. So students don't get a lot of practice at verbalizing things. And it's good when you have to verbalize it, because it teaches you a little bit about the math. Just having to verbalize it. This one here, how are we going to put that in exponential format? What is that? 7 to what power?
Exponential form, the square root of 7 to the fourth power.
Now, here's the way you do it.
Well, wait,
Take whatever's in the radical.
It's 7 to the third power, right?
No.
Crap.
A square root means to the 1/2 power. That's what square root means. Just like fifth root meant to the 1/5 power. In other words, that's always the root. Now, apply the rules of exponents. What do you have?
4.5.
Leave it as an improper fraction always. Do not convert to proper fractions, ever.
So...
Multiply those two.
Oh. Okay. Just 2.5, I guess, or just 2.5? Just...
Not 2.5, 5 halves. They're the same number. I'm just saying that in all math that's higher math, you don't use proper fractions, you use improper fractions. They're more valuable. It's much more valuable to have a 5 halves than it is a 2.5. A lot of calculus depends on that exponent, starts out with the exponent. So improper fractions, 5/2, are much better than 7 to the 2.5 power. That's not nearly as valuable for doing whatever we need to do with that answer.
Okay.
What's the first step on a problem like this?
Should we subtract the 5?
Yeah, you want to isolate that.
Yeah.
Because once we isolate that, then we can square both sides and get rid of the radical sign. In other words, you're always looking to get rid of the radical sign. But you can't square both sides until you get that isolated. And in order to isolate it, I got to subtract 5. So now I have this equals 7. Now what's the next step? Got to get rid of the radical sign. How do you get rid of the radical sign?
Square it?
Huh? Not yet. You can't square one side of an equation only. That's illegal.
Oh yes, I mean square the whole thing. So.
Okay, so what do you get when you square both sides?
You get x plus 11 squared equals 49.
Just x plus 11 equals 49. In other words,
oh yeah, that's right.
That side, the whole reason I'm squaring it is so that will cancel with that radical.
Yeah, I was thinking in my head like with a square root.
Okay. And now there's one more step. You got to subtract 11 from both sides. So there's your answer.
Yeah. So x equals 38. Yeah, I get that.
Okay. Piecewise and composite. This is the easiest subject that...
We actually did this together.
Well, I was going to say, these piecewise functions give my students more trouble than almost anything else in math, and yet they shouldn't. Is all you have to do is look at it as 3 different types of functions, or 3 different functions. What's the answer? What is g of minus 1.5? First of all, determine, here's a, where you start. That's always where you start on these piecewise functions. It's in the upper right, the top upper right domain. Okay? That's where you always look to start these kind of problems. If I was graphing this, I'm just going to go through a very quick graph just to show you how I would graph it. Well, this range is between -1 and -3, right? So what it's really telling me is that in that zone, and by that I mean that entire zone, my function needs to be 4x.
Yeah.
Well, 4x would be something like this. I can get it so that it doesn't erase. Okay. 4x would be maybe look like that. The closed dot there and a closed dot there. Okay? So I've handled that zone. Now the next zone would be from -1 to 3. Well, here's +3 over here. So if I were to draw this imaginary dotted line, now I got to deal in this zone. Okay, and in that zone, the problem is 6 plus x, which is a line that going to go through 6, has a slope of 1, going to look like that, and it's open circled on the left because it's that.
Yeah.
And it's closed circled on the right because this one is a less than or equal. And the bottom one, I hate the way they've written it. The typical way to write that would be this way. Means the same thing, but still it's this zone all the way out to infinity, right? Whenever x is greater than 3, then the answer is 12, which is just a horizontal line. It goes all the way out to infinity. So that's how I would graph that piecewise function. Now, to answer the question that they ask, what is, I'm going to erase it because we really don't need it anymore. Which function are we dealing with, the top, middle, or bottom, when we're looking at g of minus 1.5?
4x.
Okay, plug in minus 1.5, and what is 4x equal to?
-10.
Plug in minus 1. You have your calculator in front of you, Dominic?
Is it not? Oh. Whoops.
Multiply 4 times 1.5. What do you get?
Oh, it's not -1.5? Oh, it's 6.
Yeah, it is negative 1.5, but you were getting the number wrong, not the sign.
Yeah.
That's
I was putting it in as 2.5 in my head.
Okay. So anyway, yeah, to figure out what g of some number is, first of all, you have to figure out which function you're dealing with. Are you dealing with the top, the middle, or the bottom? What would g of 4 be?
G of 4 would be 6 plus x. Wait, no. It's 12, sorry.
Good. All right. Let's go down to next. We're missing some multiple choice answers here?
I don't think so.
Well, it says which of the following functions correctly returns the amount of money you would pay. So, in other words,
it must be.
We are missing them, but we don't need them. Let's let x equal the number of hours that you park. Okay? Always the first step in a word problem is to define your variables, and I mean define them. Put exactly what they mean. So, what should your charge be? As a function of x.
It is... Okay. X equals the number of hours parked, so it's...
What if you park there for 2 hours? What would it be?
Parked there for 2 hours, it's 2...
20
times
just
what?
$20. $20
Yeah.
for the first 2 hours. If you park there for 2 minutes, it's $20.
Yeah. Okay. So it's 20 times. No, it's 20 plus 5 times x.
Actually, because
Or no, minus 2. X minus 2.
there you go. Perfect. X minus 2 times 5. Okay? And now, just to see if we're right, if X were 2, what would your charge be? If you park there exactly 2 hours. In other words, we're testing this formula. We think that's right, but let's check a couple of numbers that it'd be easy enough to figure it out. If I park there exactly 2 hours, what does this formula give me as my charge?
That would make it. Wait, you said for 2 hours?
Huh?
You said it for 2 hours. What's the charge?
Yep.
Just 20.
Good. Is that correct, first of all?
Yeah, because it's
Okay.
2
About
is
3 hours.
3 hours is 20 plus 1 times 5, which is 25, which is right.
Is that correct? Okay. That's pretty much all we need to confirm that we got it right. In other words, if you park there for 4 hours, then it's 2 hours over 2 hours, so you'd pay an extra 10, so you'd pay 20 plus 10. Okay. Now, this works as long as you're there for at least 2 hours. If I were to say, what's the charge for parking there for 1 hour, this would actually produce this, which isn't correct. So this function isn't completely correct. What would make it correct is if I put absolute value signs around that. Even that doesn't make it correct, but it's closer. I suspect that if we were looking at multiple choice, this would be the answer. This would be what they would give you as one of the answers. Now, they may simplify that. In other words, clearly I can simplify that, right?
Yeah.
Clearly that becomes 10 plus 5x. So that's really your charge. If you park there for 2 hours, it's $20. If you park there for 3 hours, it's $25, and so forth. So it could be simplified and should be. Now, the reason they made this multiple choice, and I don't know why they didn't give us the multiple choice answers, but I know why they made it a multiple choice problem, and that is to handle what happens if x is less than 2. Clearly, this answer doesn't work if x is 1. Then the charge should be, it's not $15. The charge is always $20, minimum. So that's why they gave you multiple choice. All right, let's go on to the next one. Tell me what f of minus 1 is.
F of y
Minus 1. F of minus 1. What is it? What number?
minus 1. It is minus 7.
Okay. In other words, what you always do is you plug in whatever is inside the parentheses for x. That's the answer. Always. Okay? Well, now, what is g? If I said, what is g of f of minus 1, that's the same thing as saying, what is g of minus 7, right?
Mm-hmm.
Figured out that f of minus 1 was minus 7, so now tell me what g of minus 7 is.
G of minus 7 is -6.
These problems are simple. You just have to go about them in a method, the same method each time. In other words, take this very complicated expression and work from the inside out. First figure out what f of minus 1 is. We did that. Now the thing turns into g of minus 7, which is much simpler. Now we can figure out what g of minus 7 is. Okay? So always work from the inside out. Well, they don't give you many problems on these. That was supposed to be piecewise and composite functions. We got one question on piecewise and one question on composite, and I'm not sure what question 2 was. That was just a algebra word problem.
I guess.
Yeah, they don't give you a lot of stuff. All right. All right. Probability and counting theory. First of all, do you know what this 3 choose 2? How to figure that out?
3 choose 2.
Uh-huh.
What's the answer?
That's the way it's pronounced.
Yeah.
And what it is n choose r is always n factorial in the numerator, and in the denominator it's n minus r factorial. And the way I kind of remember these are, there's the same number of n's as there are r's, so this needs another r factorial. Now I got 2 r's and 2 n's. So 3 choose 2 would be 3 factorial divided by 2 factorial times 1 factorial. With me?
Yeah. So far.
What's the answer to 3 factorial divided by 2 factorial times 1 factorial? Let's see if we can do these without the calculator. I know your calculator has a combination key on it, but you need to be able to understand what that means. First of all, what's 3 factorial mean?
3 factorial is 3 times 2 times 1.
Okay, so that's 3 times 2 times 1, and I'm dividing it by 2 factorial, which is 2 times 1, times 1 factorial, which is just 1. Well, notice that that 2 times 1 cancels with that 2 times 1, and I'm left with just 3. So that's the answer to 3 choose 2, is 3. Now, the next problem is you have 12 things to choose from, and you can choose any 3. N is always greater than R, always. You never have an expression that would say this. Okay?
Yeah.
Okay. So 12 choose 3 is what? How can I write that?
Like as an answer?
In other words, using this formula, n choose r, and they give you this at the beginning. In other words, if I were to scroll up, they give you this, what this is. So you don't have to memorize that, but you have to know how to plug it in. So plug it in for me.
So 12 factorial over 9 factorial times 3 factorial.
Yeah, and
then you have to cancel something, I remember.
well, everything, this 12 factorial means 12 times 10 times 9 and so forth.
Yeah.
Notice the 12 times 11 times 10, everything below that's going to be canceled out by that 9 factorial. So this becomes 12 times
11 times 10
all over 3
3.
2.
Yeah.
And now I can do a lot of canceling. I can cancel that with that. I can cancel that with that. And so my answer is 4 times 5 times 11, 220. That's how many different ways you can choose 3 items out of 12 choices. In other words, let's say you had a 12-course meal. Well, let's say there were 12 items on the menu. And they said you get to pick any 3 of them. How many different meals could you pick? It would be 220. That's how many different type meals you could arrange. In other words, you might have one meal that's turkey salad and pumpkin pie, and another meal that's chicken, french fries, and apple pie. But if you have 12 different choices and you can only choose 3 of them, it's 12 choose 3. So you need to be able to take that, put it into that, and then simplify that into a number. Now, it's true that your calculator, I don't know if you know how to do it on your calculator, but your calculator has a choose button where you put in the N and the R. What kind of calculator do you have, Dominic?
I actually don't have that great of one, but I might be able to borrow one.
Well, you may not. You probably are not going to need a calculator for these. My guess is that all the problems they give you, you're going to be able to do manually, just like I did it. I didn't need a calculator to come up with 220. I just needed to know how to reduce 12 factorial divided by 9 factorial times 3 factorial. Here, let me test you there. That's the most important skill. So let me give you a couple.
Okay.
8 choose 5 would be what? Give it to me in factorial first. Numerator is always the n. Okay, so that's always where you start. What's the denominator?
8 minus 5. Wait, so 3 factorial times 5 factorial.
Correct.
Or just, yeah.
Now, let's simplify that. The simplification is not as obvious as you might think. What can I do with this and this? What does that turn into?
That is...
What's 8 factorial divided by 5 factorial?
8 times 7 times 6.
Good. That's a key step. And then we're dividing that by 3 factorial, which is 3 times 2. Well, that 3 times 2 cancels with that. That's the answer. Okay?
Mm-hmm.
Now, next one's a little tougher. Trying to figure out what the best way to show you this. If I had this word, how many different ways could I rearrange those letters? Well, or pick one. You've had permutations, correct or not?
Yeah, I don't remember the formula though.
Well, the formula is very similar.
Isn't there an easy way to do these things though? I know that when there's multiple different of the same letters, and it's pretty complicated.
Yeah, there is an easy way to do it, but first of all, let's talk about the general formula. You always want to start with the general formula. And not a C, it's an R. N pick R. Okay? N pick R is n factorial over n minus r factorial. It's actually simpler than the choose. Notice that the choose is this. In other words, it's very similar, only there's an extra r factorial for the choose. So this is almost exactly the same as for permutation, only missing the r factorial in the bottom. With me?
Uh-huh.
Okay. So let's do 5, pick 3. Translate that to factorial terminology for me. Goes in the numerator.
The 5
factorial.
Factorial.
Goes in the denominator.
The r factorial.
No, just the n minus r. Just that.
So yeah, okay, yeah.
So the permutations are actually a lot easier. In other words, if I turn this p into a c, then the bottom is 2 factorial times 3 factorial. But if it's a pick, not a choose, then the bottom is strictly n minus r factorial.
Okay.
Okay, and of course that would be 5 times 4 times 3. That would be your answer, 60. Okay. Now, this question says how many different ways can you rearrange the letters in Gibbons? Well, let's go back to the first one, gate. How many different ways could I rearrange the letters? Well, that ends up being 4 pick 1.
Isn't it just 4 factorial?
Which is?
4 pick 1.
No, not really. It's
no?
4, yeah, no, you're right. It is 4 factorial.
Because it's the first letter can go in 4 different places, the second go in 3.
In other words, there's
so
4 different letters you can put there, and then there's 3 there, and then there's 2 there, and then there's 1 there. So what it is the number of different letters factorial. So for gate, it would be 4 factorial, and that would be the answer. But if I had GATET,
yeah, I know. When there's two of the same,
it would be 5 factorial divided by 2 factorial. In other words, it's the number of letters divided by the number of duplicates. So for Gibbons, there's 1, 2, 3, 4, 5, 6, 7 letters. So it's 7 factorial divided, and there's only 2 duplicates. So the answer would be 7 times 6 times 5 times 4 times 3. That's how many different ways you could rearrange the letters. All right. Go to the next one. Let's see, we got about 9 minutes. These are always the hard problems, these combinations and permutations. I know a few subjects in math that are more difficult to get a handle on than these. Except this one. This is easy. Remember the problem where I said if you have 12 different choices for a meal, how many different ways could you pull out 3 items? And it was 12, choose 3.
Yeah.
Well, let's say you have 4 entrees. You know what an entree is? That's either meat, turkey, meatloaf, whatever. And you have 3 drinks. And you have 5 desserts. That's your choice. In other words, you have turkey, chicken, ham, or beef for your entrees. For your drinks, you have milk, orange juice, or tomato juice. For your desserts, name 5 desserts. How many different meals could you make where you would take 1 item of each? Well, it would be 4 times 3 times 5. That's the answer.
Wait, that's it?
Well, that's the answer for my theoretical problem. In other words, if I have 4 entrees, 3 drinks, and 5 desserts, then I can choose this many combinations of meals.
Oh yeah, that's how it's always worked. Like if it's just
if
there's so it's just 5 times 3 times 10 for number 3.
Well, that's the question. Is that usually yes? It's that straightforward. And I think that's the answer. How could we tell? Let's simplify everything. Let's give ourselves 2 comedies. In other words, we're trying to figure out if the formula is correct. 2 comedies, 1 drama, and 1 action movie. How many different ways can I watch the movie?
2.
Well, it's if that formula is correct, yes, the answer has to be 2. It's correct. 2 is right because you either watch 1 comedy, 1 drama, and 1 action movie, or you can watch the other comedy and the same drama and the other action movie. Okay? So it appears that we're correct. It's 5 times 3 times 10.
Yep.
We can get started on this section. We're not going to get that far with it, but kind of find it interesting that they call these sample problems, but they don't give you the answer. Do they give you the answer somewhere on these?
Well, the sample problem is just, I think it's just the graph is what we're doing the problems on.
Okay. All right. So what's the probability that a person selected at random prefers vanilla ice cream?
Huh? What's the probability the person selected at random prefers vanilla ice cream?
Uh-huh.
So there's 300 people total.
Okay.
And there's 95 people who like vanilla ice cream.
Okay.
So it's 95 out of 300.
Perfect. What's the probability that a person selected at random is either 20 to 30 years old or prefers chocolate ice cream?
20 to 30 or prefers chocolate. 20 to 30 or prefers chocolate. It's
What's the odds that they're 20 to 30 years old?
105 out of 300.
Well, hold on. Okay, 105 out of 300, yeah. Or they prefer chocolate, which means that and that. There's 60 other people that prefer chocolate, right, that are not 20 to 30 years old. So I would have to add to that 60 over 300. So the probability is 165 over 300. In other words, you take not only that number divided by the total, but plus the other two categories of people that like chocolate but are not in the 20 to 30 age group.
Yeah, that's what I was doing in my head. I was like,
Okay. Again, these can be tricky, these probability problems. What's the probability prefers vanilla ice? Okay, here. What's the probability that a person prefers vanilla ice cream is 30 to 40 years old? What ratio is that going to be? First of all, what's the universe of people that like vanilla ice cream? How many?
95 out of 300.
So forget the 300, the 95. We're only talking
about 95.
People that like vanilla ice cream. And what percentage of them, or how many
25.
of those?
25 out of 95, yeah.
That's the answer. In other words, we didn't care about that. We've eliminated that. They've narrowed it down to this column only when they ask the problem. That's a good place to stop.
Okay.
Than tackling another subject.
Yeah. Okay.
Let's see. You want me to bring my calendar up? You had mentioned that you might want more sessions.
Can I text you?
Absolutely. In fact, here's the best way to do it, Dominic. You've never done it this way because we've always had a scheduled one, but go to this website, hold on, and I use an online scheduler. So it will show you my complete availability and let you schedule it without talking to me. Let me tell you, this is a great app to have on my website. Go there, hit schedule a session. It'll give you a calendar, let you pick any date you want, shows you my complete availability. Remember, all times are in Mountain Time, and schedule a session. And what happens is I get a text on my phone that tells me somebody scheduled a session. Well, it would tell me that Dominic scheduled a session from 4 to 5. Okay? That's the best way to do it. Now, I certainly don't mind doing it manually, especially in the summertime, because I don't have very many sessions. But during the school year, you can imagine that it's quite difficult for me to explain my availability. You know, what am I going to say? I'm available between 10 and 10:30, and then again between 1 and 2, and then again between 2:30 and 3. In other words, it becomes almost impossible to describe your availability. So these scheduling programs work great because they give you a table showing one's complete availability and letting you pick a half hour or an hour out of that schedule. So that's the best way to do it. But you're always welcome to text me, especially over the next week, because I don't think I have anybody else scheduled. I usually give myself a couple hours for lunch in the summertime, so I'm not going to be available from like noon to 2 my time. But other than that, I'm going to be available 9 a.m. to 9 p.m. my time.
Okay.
Okay?
Well, I think I'm probably going to get at least another 1 or 2 sessions before.
That's wonderful. I love it. You could have a session per day as far as I'm concerned until your test. I'm not sure you can do. Yeah,
I was going to take I was thinking I was going to take a break tomorrow just because it was Friday.
Right. It looks like we're, what, 2/3 of the way through this material?
Yeah, pretty much.
Yeah, just judging where the scroll bar was. So I would think another hour and a half and we could certainly cover it, maybe even in an hour. I don't know.
Okay.
It's a lot of material. You're basically trying to cover all of Algebra 2 in a short period of time, which is fine, but you can only go so fast, you know. And like I said, they're only giving you like 1 problem per subject matter here. They should be giving you 2 or 3 problems per subject matter. So they're doing the condensed version, which doesn't help you that much, but nonetheless. All right, Dominic, I will talk to you next time.
Okay. I'll talk to you next time. Have a good one.